So we are looking at our Unit 4 test review today. Our first standard is to be able to write the equation for a line given slope in some format that can be on the graph or given. So number one, write the equation of a line with a slope of -3 and a y-intercept of 4. So we know that slope-intercept form of a line is y equals mx plus b. This tells us that our slope m is -3 and our y-intercept b is 4. So the equation of this line would just be y equals -3x plus 4. Number two, we have write the equation of the line that goes through the point 6, -2 and has a slope of 1/3. So here we're not given the y-intercept like we were in number one, but we're given enough information that we can figure that out. So we are given an x, y, an ordered pair, and we're given the slope m equals 1/3. So instead of saying y equals mx plus b, we will say -2 equals, instead of m, we will substitute in 1/3. Instead of x, we'll write 6. And because I know I'm working with fractions, I'll go ahead and write that as 6/1 plus b. And that's enough information for me to calculate b. So I'll break down the -2 equals 1/3 times 6, or 1/3 of 6 is 2 plus b. And then we subtract 2 from each side to get b equals -4. So this gives us our equation y equals 1/3 x minus 4. Number three, write the equation of the line that goes through the point -8, -3 and has a slope of -3/4. So again, we're given an ordered pair and the slope. So we have our x and y value, and then we have our m value. And we're substituting this into, let's go ahead for this, we use point, for this one we use point slope intercept form, excuse me. So for this one, let's use point slope form. So we're practicing with both, and point slope form it's probably, it actually makes a little more sense because we're given the point and the slope for this one. Either method will work though. So whatever you're most comfortable with. Okay, so point slope form of a line is y minus y sub 1 equals m times the quantity x minus x sub 1. So we can do y minus, and our y value is -3. So minus -3 is the same as plus 3 equals -3/4 times the quantity x minus -8, which is the same as x plus 8. So then we have y plus 3 equals -3/4 x minus, because a negative times a positive is a negative. We multiply 3/4 times 8. 8 times 3 is 24, divided by 4 is 6. Okay, and then we subtract 3 from each side to isolate our variable y, and then I'll just write this here so it's not blending in with number 5. This gives us y equals -3/4 x. I forgot to distribute the x there, so I just added it in, minus 9. So y equals -3/4 x minus 9. Number 4, we have a slope of 0. So as soon as we see that slope of 0, we know that that is going to be a horizontal line, because horizontal lines have a slope of 0. So that means it's going to go through our y-axis at 2. So the equation of this line is y equals 2. If it helps you, you can make a visual aid. You can make a graph and plot that point, -4, 2, and then plot additional points, and you'll see that all of the y value is equal to. I'll just go ahead and do that just as a refresher. So if you're not sure, you can always make a graph. Okay, the point is -4, 2. So here's -4, 2. Okay, and then let's just add, we know it has a slope of 0, so we know it's a horizontal line. So then we can plot this point, 0, 2. Let's plot this point, 4, 2. Okay, we see all of the y values are equal to 2 for that line, which tells us that the equation of the line is y equals 2. Okay, so if you can do it right from here from the equation, that's fine. If you need a visual aid and you prefer to make and you want to see it visually, you can make the graph in a table of values. So it's really obvious. Okay. Number 5, we're given a graph and we're asked to write the equation of the graph. We can see the y-intercept on these graphs, so we'll just go ahead and write those, and we can obviously see the slope, so we'll go ahead and write those in slope-intercept form. Our y-intercept for this graph is -4, and our slope, remember that's our rise over run. We just make a reference triangle anywhere. Rise is 1, run is 1. It has a positive slope, so m is equal to +1. So y equals 1x, and I don't need to write the 1 in front of that. It's an understood 1 minus 4. You can write the 1 there if you prefer, but it's really more simplified if you don't. So y equals x minus 4. Number 6, we can see that our line has a negative slope. Okay, we can see that our line goes through the y-axis at -2. Okay, and we can look at our slope and make a reference triangle to determine what the slope is. Our rise is 1, 2, 3, and our run is 2. Okay, so rise over run, 3 over 2. So the equation of this line would be y equals -3 halves x minus 2. Okay, let's go on to the next page. Okay, the standard is that we will be able to write the equation of the line that goes through 2 given points. So number 7, write the equation of the line that goes through 1, 4, and 3, -8. So we want to start off by finding the slope of the line. So our change in y, I'll do -8 minus 4, and then go in that same corresponding order for the x values, 3 minus 1. Okay, never subtract, add the opposite. -8 plus -4 is -12. 3 minus 1 is 2, so m is equal to -6. Okay, then once we have m, we can substitute in either point and solve for b. So let's go ahead and do that. Y equals mx plus b. Our y value, I'll choose the smaller values. 4 is equal to -6 times 1 plus b. 4 is equal to -6 plus b. Add 6 to each side. B is equal to 10. Okay, so we know m is -6 and b is equal to 10. So the equation of the line is y equals -6x plus 10. Number 8, write the equation of the line that goes through the point 4, -1 and -4, -5. So again, our slope is change in y over change in x. So I'll do -5 minus -1 over, and go in that same corresponding order for the x values, -4 minus 4. Never subtract, add the opposite. So we have -5 plus 1, which is -4, over, never subtract, add the opposite. -4 plus -4 is -8. So this simplifies to a positive because a negative divided by negative is a positive 1/2. So our slope is positive 1/2. Okay, and then I can use slope-intercept form like I did here. I know some of you still prefer that, but let's go ahead and use point slope form because that's just another way to do this. It doesn't really matter which point you use. I'll just use the first one. So remember, point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. So we'll have y minus, and I'll use the first point, -1. So it's y plus 1 equals 1/2 x minus x sub 1. So x minus 4. Distribute the 1/2. So we have y plus 1 equals 1/2 x minus 2. And then subtract 1 from each side. I'll write that really small. to get y equals 1/2 x minus 3. Number 9, write the equation of the line that goes through the point 4, -3 and -6, -3. So our slope is change in y over change in x, -3 minus -3 over -6 minus 4. Okay, if we do never subtract, add the opposite for our integer work. Add the opposite. We have -3 plus 3, which is 0. Never subtract, add the opposite. -6 plus -4 is -10. As soon as I see that, I should have noticed this right away. Okay, but it's okay. Whenever you notice it is when you notice it. So we have 0 over -10 is 0. Okay, so we know we have a slope of 0. That tells us, hey, the line is going to be horizontal. So now that we know the line is horizontal, we look back here, and if I had been if I'd slowed down a little bit, I would have noticed right away both of my y values are -3. Okay, so as soon as I see both of my y values are -3, I actually didn't need to do this at all. And find the slope, I can just write y equals -3. That's the equation of our line. We know it's going to be a horizontal line. That's going to go through the y-axis at -3. Okay, and so now I'm just looking ahead and I notice number 12, the equation of this line. What's the equation of this line going to be? X equals 7. Okay, so I don't need to go through the whole process. I can see that's going to be a vertical line that goes through the x-axis at 7. All of the x values are going to be 7. So the equation of this line is just x equals 7. So we're finished with number 12 now. Okay, so let's move on to number 10. Write the equation of the line that goes through the point 0, 2, and 5, -3. So our change in y, let's find our slope first by getting change in y over change in x. Okay, -3 minus 2 over change in x, 5 minus 0. So this is -5 over 5. So our slope is -1. And then you can substitute, let's go ahead and do point slope form. Okay, y minus y sub 1 equals m times the quantity x minus x sub 1. Y minus, and I'll choose the first point because I don't really want to have a negative value. That's just my personal preference. So y minus 2 equals m, which is -1, times the quantity x minus 0. Okay, so here I don't really need to distribute. I can just do x minus 0 as x. Okay, -1 times x is just -x. And then I bring down the y minus 2 equals, then I add 2 to each side to get y equals, and I'll just write this here so it's not so crowded, y equals -x plus 2. All right, and then let's look ahead to number 11. Write the equation of the line that goes through the point 2, -6 and -2, 4. So our slope is change in y over change in x, 4 minus 6 over -2 minus 2. 4 minus 6 is -2. -2 minus 2, you could do never subtract, add the opposite is -4. A negative divided by negative is a positive. 2/4 simplifies to 1/2. So our slope is 1/2. And then you can use slope intercept form, or you can use point slope form, whatever you prefer. It looks like we've done a little bit more with point slope form than slope intercept. So let's just go ahead and do this one in slope intercept form. Although it is actually a little simpler to do point slope form, I just want you to remember both. We're going to reinforce both equations. So y equals mx plus b. Okay, I'll choose 2, 6 as the point I want to substitute in. So 6 equals 1/2 times 2 plus b. Half of 2 is 1, so 6 equals 1 plus b. Subtract 1 from each side to get b equals 5. So the equation of this line is y equals 1/2 x plus 5. Okay, we already did number 12 because we saw both of those x values were 7. So we're finished with number 12. And then 13 and 14, we need to write the equation of the line given a table. All right, number 13, if you look at that table, this is a really helpful table because they told us the y-intercept. Okay, remember the y-intercept is when x equals 0. So if you think of your or your coordinate plane, okay, 0, 4, that is where your line crosses the y-axis. Okay, so this tells us b equals 4. All right, I'm going to slide that down a little lower so we can use our table of values. So we can use our table of values to help us to calculate slope. All right, so now these are working, if you look at your x values, they do have a consistent interval, right? As you read this, you can see it's increasing by 4 each time. So that's helpful for us to be able to find the slope of this line. So let's look at the first level differences. Okay, so all the x values are increasing by 4. As x increases by 4, y decreases by 3 because 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is -2. -2 minus 3 is 5. So that's really helpful because it lets us see our change in y over change in x. Our slope is going to be equal to, what was our change in y, our rise? -3. And what was our change in x? Our run, +4. So our slope is -3/4. Okay, so the tables are really helpful when we're writing the equation of a line. So the equation of this line is y equals -3/4 x plus 4. All right, y equals -3/4 x plus 4. If you hate writing equations of lines from the tables, I kind of like it. If there's a consistent interval of change, even if there's not a consistent interval of change, like if this went +8, let's say they skipped this row. I'm going to cover it up with my pen. So let's say they skipped this row right here. Okay, what would have happened here is you would have had, instead of a +4, you would have had a +8. And instead of a -3 here, we would have had a -6. And it would still be proportional because it would still work out. Change in y over change in x, rise over run. So -3 over +8, or excuse me, if we had a -6 here, it would be -6 over +8. Rise over run would still simplify to -3/4. Okay, so as long as you're looking for that proportionality, you can still use the table to help you to find the slope of the line. Okay, let's look ahead to number 14. Um, I'm kind of, I don't really want to calculate b. I'm being a little bit, let's see if we have a constant rate of change, and then I'll tell you what I'm thinking. So first of all, we want to check and make sure it is a straight line. We can't just assume it's a line. We have to prove it, showing that we have a constant rate of change. So let's look at our x values. It's +1, +1, +1, +1. We definitely have a constant rate of change here, 3, 4, 5, 6, 7. Okay, then let's look at our y values. Okay, from 7 to 10 is an increase of 3. From 10 to 13 is an increase of 3. From 13 to 16 is an increase of 3. From 16 to 19 is an increase of 3. Okay, so really we know our slope is change in y over change in x. We know our slope is +3 over +1. So we know our slope is 3. And then we can plug in m, any x, any y, and then we can calculate the slope that way. But you know me, I'm just going to cut corners when I can, and not cut corners in a bad way, but just be efficient with our time. So I am just going to work backwards, and I'm going to solve for b using my table. Why not? I already have this really nice organized structure. Okay, so 3, oh, I did a little bit too much. That's fine. Okay, so 3, 2, 1, 0. This is going to be my y-intercept. Okay, so if this is faster for you, you can feel free to do it that way, or obviously you can do it algebraically as well. So if 19, 16, 13, 10, -3 is 7, -3 is 4, -3 is 1, -3 is 0, -1, -2, -3, and we don't need to go this far, but I already made the box, so we're going to fill it in. Okay, so then we can check it and make sure, is this a +3? Yes. Is that a +3? Yes. Is that a +3? Okay, so we see those first level differences. We can extend the table, um, which I know the writers of this problem stopped the table there because they wanted us to substitute and find B, but we did this a few times up here already. Okay, so we can also learn this little um, um, strategy of extending the table to save us a few moments, especially when we're taking time tests like the PSAT. Okay, so we see that B is equal to -2. So the equation of this line is y equals 3x minus 2. Okay, 15. And this standard is I can write an equation that is used to solve problems. Um, you are training for the biking portion of an Ironman triathlon. You want to gradually increase the number of miles you bike each day. Currently, you bike 20 miles each day. Your plan is to bike 4 additional miles each day. Write an equation to model how many miles you bike each day as a function of the numbers of days, and determine how many miles you will bike after 2 weeks. Okay. So right now our starting point is that we are at 0 is our starting point is per day. So X we're measuring in days, and Y we're measuring in miles. And if you're not sure how we determine that, remember time is usually on the x-axis. Okay, so that's the number of days. So at 0 days, we're biking 20 miles each day. So today is the first or the beginning day. We're biking 20 miles. Your plan is to bike 4 additional miles each day. So after a day passes, on that day, we're going to be riding 24 miles. The second day will be 28 miles, etc. So write an equation to model how many miles per day as a function of the number of days. Okay, so our equation will be our increase here is 4 additional miles per each additional day. So that's our rate of increase is 4. Our rate of increase is m, our slope. Okay, our starting amount to where we are here is 20. So at the beginning, that's our current number of miles per day is 20. So the equation would be y equals 4x plus 20. And then it asks us to determine, so that's the first thing we're asked to do. Then it asks us to determine how many miles you will bike after 2 weeks. Okay, so we're assuming that they're training 7 days a week. We're not told otherwise, so we're going to assume that a week is defined as 7 days, and they're increasing 4 miles per day each day. So here, what they're asking us to do is when x is equal to 2 weeks, 14, to solve for y. So that's the value we're being asked to find. So we'll go ahead and substitute that in. X is 14. So y is equal to 4 times 14 plus 20. Okay, so y is equal to 4 times 4 is 16. Write the 6, carry the 1. 4 times 1 is 4, plus the 1 we carried is 5. So y is equal to 76 miles. So 76 miles per day after 2 weeks or at 2 weeks. Okay, because we're assuming that they're increasing the number of miles each day. Number 16, at the end of the year, your dad told you that he would buy you a car when he gets enough money saved. He started saving in January, and you found 2 of his bank statements. The balance of the April bank statement, and so April's the 4th month. Let's just go started saving in January. Okay, so the balance of the April bank statement was $1,300, and the balance of the July statement was $1,900. Write an equation to model the amount of money saved as a function of the number of months saved. Okay, so January is our starting point. Okay, so X, y. Okay, and then, so we're going to call January our first month, our starting point, and I'm just gonna call that 1, and we're gonna solve for this value right here, okay? Write an equation to model the amount of money saved as a function of the number of months saved. How many months will it take to save the additional $2,500 needed to save the $2,500 needed to buy the car? Okay, so January is our starting point. So let's actually just call that 0 as it is described in the problem. So I don't love that because typically we think of January and we think of the number 1 for the month number. So, but since it's the starting point in our equation, we have to call it for the number of months, our starting point is 0. Okay, so February is 1. March is 2, April is 3, May is 4, June is 5, July is 6. So it's very, um, it's it's a little different. I wish we would have started saving in December just to make it easier, but that's okay. All right. So the balance of the April bank statement was $1,300. So April was the third month that he had saved because January is the starting point. So February would be 1 month. Okay. March would be 2 months. April would be 3 months since he started saving. So 3 months since he started saving, he had saved $1,300. And then the balance of the July statement, which was the 6th month that he had been saving, the balance was $1,900. Okay, so first we have to write the equation, and then we have to find out how many months will it take to earn $2,500. Okay, so our equation, we can do change in y over change in x, okay, or we can just subtract this here with our table. So we'll go ahead and do it algebraically, excuse me. 1900 minus 1300, and our change in x is 6 minus 3. Okay, so 1900 minus 1300 is 600. 6 minus 3 is 3. So our rate of change is 200. So $200 per month is being saved. Okay, so remember, this is dollars, this is months. So we're rate of savings is $200 per month. We can go ahead and calculate B by using our point slope form. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. So y minus 1300 is equal to m, which is 200 times x. We use 1300, so we need to use 3 minus 3. So y minus 1300 equals 200x minus 600. And then we'll add 1300 to each side to isolate y. Okay, so y is equal to 200x plus, plus 700. So that means when we started out in January, there was $700 already saved. And then so that's the first thing we were asked to do. And the next thing we're asked to do is to find out how many months it will take to save the $2,500 needed to buy the car. So here we want to know when our total is $2,500. So we'll say the equation will be 2,500 equals 200x plus 700. So kind of going to squeeze this in right here, and I'll just write really small. But y equals, instead of y equals, we'll say 2,500 equals 200x plus 700, and subtract 700 from each side. Okay, so this is 200x. So 2,500 minus 700. So instead, I'm just gonna minus 500 is 2,000, minus 200 more is 1,800. And then divide each side. I'm running out of side room, so I'm gonna skip showing that step, but divide by 200 1800 divided by 200 is proportional to 18 divided by 2, so 9. It will take 9 months to save $2,500. Okay. And then at the end of that 9 months, you have enough money to buy that car. 17, Tina started a printing company. The table below shows the company bank account. Sorry, I'm going to slide this just a little bit over. Tina started a printing company. The table below shows the company bank account balance based on the number of months the company has been open. Write an equation that models the printing company bank account balance as a function of the number of months since the company opened. Okay, no problem. So number of months since the company opened, they gave that to us in a nice organized table. And then the net balance, that's given to us in the table as well. So we'll call these X and Y. And then we're asked to find out how much will the company have in the account 2 years after opening? And then how many months will it take for Tina to have enough money to purchase new equipment for the business that will cost $25,675? Okay, so great business modeling question. And so first of all, let's choose these two values to, I grab my calculator for this one. Okay, to go ahead and calculate our slope. So our slope is going to be change in y over change in x. I'm just going to choose these two values right here. So change in y, 5,275 minus 2,725. And then go in that same corresponding order with your x values, 5 minus 2. Okay, 2,550. Over 3 is 850. Okay, so that means that your business is earning a profit of $850 per month. So after expenses, salaries, investments, things like that, you're clearing $850 per month. Okay, then we need to find our y value. So let's go ahead and substitute in either any of the x values. We'll choose the first one. So in point slope form, y minus 2725 equals m, which is 850, times x minus 2. Okay, so I use point slope form. I use this point and the slope. Okay, and then add 2,725 to each side to get y equals 850x, and equals 1,000, or excuse me, plus 1,025. So that's the equation. Write an equation that models the printing company bank account balance as a function of the number of months since the company opened. Okay, so this means that your profit is $850 per month. So when you opened, you had a $1,025 balance. The next thing we are asked to find is how much money will the company have in the account 2 years after opening. So this is number of months. So 2 years after opening is x equals 24. So let x equal 24, and we'll substitute that in and solve. So how much money will you have in your bank account balance after 2 years for your printing company? So y equals, instead of 850x, we'll say 850 times 24 months. So 850 times 24 plus your starting balance, which is 1,025. So 850 times 24 plus 1,025 is $21,425. Okay, so how much money will the company have? $21,425. And then how many months will it take for Tina to have enough money to purchase new equipment that will cost $25,675? So obviously a little bit longer than 24 months, but let's find out exactly how much more. Um, so we want to know what our balance, the net balance is 25,675. So here we're being asked to let y equal 25,675. So we'll plug this into our equation and solve for how many months. So we'll have 25,675 equals 850x. So we're trying to figure out how many months at $850 per month will it take us to get to our desired amount to buy this new equipment for the business, plus 1,025. So then we can go ahead and subtract 1025 from each side, 1,025, excuse me. Okay, so 24,650 equals 850x. Divide each side by 850. 850 divided by 850 is 1. So we have 1x equals 24,650 divided by 850. So 29 months. So how many months will it take? It will take 29 months to save up the $25,675 needed. To get that new equipment for the business. And then let's go ahead. So that was a review of linear modeling. So writing the equations to represent a given situation and solving for specific time values or monetary values. Okay, and let's go on to the next section. Okay, so our next problem we have is the Townsend Realty Group invested in 5 different properties listed in the table below. The table shows the amount in dollars the company paid for each property and the corresponding monthly rental price in dollars. And the corresponding monthly rental price in dollars the company charges for the property at each of the 5 locations. The relationship between the monthly rental price R in dollars and the property's purchase price P in thousands of dollars can be represented by a linear function. Write the function to represent the relationship. Okay. So let's go ahead and do that. So let's call this, let's actually reverse these a little bit. I'm going to call this as our X and our Y. So for purchase price, we're going to represent that with P or X because I just personally prefer to work with X and Y. And for monthly rental dollars, we're going to represent that with R. And then while I'm writing the equation, I'm just going to use that with X because that's what I'm just a little bit more comfortable with. So I want to look at the rate of change, our slope. So from 128,000 to 176,000, that will be an increase of 48,000. And then from 1,832 to 2,504. That's an increase of 672. So plus 672. And our slope is our change in Y. So that's plus 672 over our change in X, which is 48,000. And then we'll go ahead and divide that out for 672 divided by 48,000, 0.014. Okay, so the change in monthly rental price per purchase dollar. Okay, so for every dollar that our purchase price went up, our that's just the ratio, the monthly price to the purchase price. Okay, so then we can go ahead and write our equation using point slope form. We'll use our slope and we'll use one of our points. We'll just use the smallest points. So y minus 1,832 equals m, which is 0.014 times the quantity x minus 128,000. Bring down the y minus 1,832 equals, we'll distribute our 0.014x. Uh, 1,792. Okay, and then we'll go ahead and simplify or solve for y. So y equals 0.014x plus 40. Okay, so y equals 0.014x plus 40. Oh, but they wanted us to write this in terms of the rental price and the purchase price in P per dollar. So instead of y equals, so our rental price is equal to 0.014 times the purchase price plus 40. Okay, so that's the relationship between the, you can calculate the rental price based on the purchase price. All right, then our next standard is just more basic translating to be able to write an equation for a relationship between values given a verbal description. So number 19, the difference. So as soon as we see difference, we know we're working with subtraction. The difference in the number of girls and boys in the 7th grade class is 34. Excuse me. So girls minus boys, G minus B equals 34. Number 20, Kim has $3 more than 3 times what Greg has saved. So Kim has, so her amount is equal to $3 more than something. So something plus 3 more. So $3 more than what? 3 times what Greg has saved. So 3G. So if I take what Greg has saved and I triple that and then add $3 more, we'll have what Kim has saved. Number 21, at the water park, passes are sold for both children and adults. This summer, the water park sold a total of 2,570 passes. Write an equation to model this situation. So children and adults. So adults passes plus children's passes equal the total of 570 passes. I almost wrote 550. So adult passes plus children's passes equals 2,570. And then 22, on Lake Columbia, we saw boats that cost $25 to rent daily and an additional $10 per gas. Write an equation to model the situation for the total cost. So when you see daily, that means per day. So $25 per day is your slope. And then we have that initial amount for gas. So our equation will be y equals 25x plus 10. Okay. And we will do the parallel and perpendicular review in another video. So that is part 1 of the Unit 4 review.